All right, hello there, everyone. These are the CIS352 course notes. This is for January 22nd. So today in class, we talked about recursive functions, a whole bunch. We did a bunch of examples of recursive functions, which I've left in this file. Some of them have been commented out. Some of them have been re-added. I did a bunch of the quick answer sessions. So some examples of things that we coded up. We talked about take, which takes the first in elements of a list. It's a pretty basic recursive function. If n is equal to 0, we return nothing because we don't want to take any more. Otherwise, we basically take the first element off the list, and then we call take with n minus 1 so that eventually it will be 0 and produce the empty list. Okay. And kind of dual to take is drop. And drop says basically just take the cdr and drop off the first thing, in this case, until you get to 0. Okay, so I think the student submitted this one as well. We talked about basically some of the project, which there's a video on that. I'll let you watch that yourself as well. It's linked on the course website. I have an example board here. I wrote out get cell again. We talked about and map and or map. So and map says, does everything in L satisfy the predicate F, which returns true or false? Or map is asking the dual question, which is saying, does there exist some X in the list L such that F returns true for X? All right. We talked about the concept of vacuous truth, which is this idea that if I say, is some predicate true on the empty set, then the answer is, or I guess I should pose this better. If I say, is it the case that for every X in the set S, some predicate holds? And the argument is basically that that should be true if the set is the empty set. And this is this idea of vacuous truth. Because the idea is that truth is something that should be refutable, right? If there's nothing that could possibly falsify truth, right, well, then it seems fair to say that that's the case. A better way maybe to see this notion of vacuous truth is the fact that if we have something like and map with even over the list 0, 2, that will eventually expand out to basically a big and of and even 0 and even 2 and now true. And because we're doing this big sequence of ands, if we have false right here, then the whole thing is going to be false. And so that's just going to make it so that the result could only ever be false, right? And so it only really makes sense to have true here, right? Because when we're and map, we're sort of pessimistic in the sense that the first time we find something that's off, we immediately say all bets are off, right? But if we don't find anything that's wrong, then we kind of have to say true. And that's tied up in this idea of vacuous truth. Okay, so we talked about that, kind of a more tricky concept, I think, from today. We talked about list winner, which is a function that I wrote on the way to sum winner. So the whole reason I was doing this is because I was trying to explain the winner function in this upcoming project. And the idea in the winner function is basically this. There is a winner to tic-tac-toe whenever you can find some row, column, or diagonal such that everything in the row, column, or diagonal is X or O. We discussed the fact that it will never be both of them. So why won't it be both of them? Well, if you start from the empty board and you just start adding, X's and O's and you swap out players between turns, then as long as you stop playing the game when the first person wins, then before that point where the first person wins, nobody will have won, right? And so that's another card of the case here. If neither X or O win, then we return false. So I scaffolded out basically one win, which you could write the function. To me, this is the most straightforward way. I don't mean to box you into a solution, but this is, the most straightforward way to do it to me. And the mechanism that we're going to sort of affect is that we're going to say, if you give me a list of lists where each of those lists is a row, column, diagonal, really doesn't matter what it is, I want to just see, does any of those sublists have the property that everything is X or everything is O? And so I wrote this function SumWinner, and I used ORMAP to do it. And then I used ListWinner right here, which this kind of uses count, which is an interesting way of doing it that is maybe not quite the same. I would probably use AndMap to write ListWinner, huh? But I pulled this out of a quick answer, which it's a fine way of doing it. Seems like a reasonable solution. So, okay, those are the notes from today. And I also put up a new quick answer test. And so I will offer some feedback on that if you'll do it. All right, thanks so much.